Okay, welcome back to part 2 of the video. On number 5, what we're going to have you do is I want you to decide which strategy you're going to use, if you're going to use substitution or elimination, and work all the way through the problem. And pause your video while you do all of that decision making and solving, and then check back for the explanation. Okay, for number 5, I went ahead and chose elimination, and mainly because I saw that I had a positive 2x and a positive 2x. So I just took my whole first equation and multiplied it by -1 so that I would have just the opposite. So when I multiplied the whole equation by -1, then it was a very simple elimination problem. Okay, so for number 6, I want you to go through the same process of making a strategy determination and solving it, and then check back for the explanation. Okay, so on this one I chose to do substitution because I had an x with a coefficient of 1. So I went ahead and just solved that first equation for x equals so that I had something to substitute in for x, and then went through the process and came out with a solution. Now looking at number 7, on number 7, we're going to run into a special situation. So just like when we were solving equations with one variable, sometimes if we have variables on both sides, sometimes they disappeared. And if you can remember, if they disappeared and what we were left with was false, then we had no solution. And if what we were left with was true, then we had infinitely many solutions. Well, the same thing happens with systems of equations. So as you're working on number 7 and 8 and deciding which strategy to use, just keep in mind that if your variables disappear on both sides, then you have to decide if you've got a false statement or a true statement and come up with the answer. So go ahead and make your decision on number 7, solve it through, and figuring out which special situation you might have, and go ahead and get the answer, then check back for the explanation. Okay, so number 7, when we started, I went ahead and chose substitution because I already had an x equals isolated all by itself. And when I did all of my substitution, I found that I had two like terms to combine of a -3y and a positive 3y. They canceled out, leaving me with 9 equals 4, which is false. So as we discussed, that gives us no solution, but tying this back into 2 days ago when we were looking at the different solutions for systems of equations, when you had no solution, that meant the lines were never going to touch. That means those lines are parallel. Okay, so number 8, again, I want you to do the same thing. I want you to decide what strategy you're going to use and come up with the answer, and then check back. Pause your video now and then check back for the explanation. Okay, number 8, if you chose elimination, all of a sudden everything eliminated. They were all opposite like terms, so they all became 0, and 0 equals 0, which is a true statement, so it was infinitely many solutions. Okay, so as we look at number 9, we're starting to look at real life situation. So we're going to put together a lot of the different things that we know how to do, and we're going to have to figure out what everything represents. So that gave us a lot of the information in the problem. So what I want you to do now is pause your video for a moment, read the whole problem so that you can understand it, and then start the video up and we'll discuss how to do it. Okay, so they were kind enough to go ahead and tell us what x is going to equal and what y is going to equal. So x is our adult ticket, and y is going to be our children's ticket. So what we have to do is come up with the two equations given to us in the situation. So when it says the adult ticket cost, that's is, so our adult ticket is, so we can go ahead and say x is our adult ticket, so x is equals 3 more than a children's ticket. So a children's ticket plus 3. So y plus 3 more. Okay, so we have our first equation. Then it says 200 adult tickets. So let's go ahead and do that. 200 adult tickets. And means plus, so plus 100 children tickets. Children tickets are Y, are sold. And they had a total revenue of $2,100. So now we have our systems of equations. What I want you to do now is taking this system of equations, decide if you're going to use substitution or elimination, and go ahead and solve it and find out what the answer is. And the question is, what is the cost of a child's ticket? So that's what you're coming up to an answer. Pause your video, do the work, and then check back for the solution. Okay, so after I did my substitution, I substituted the y plus 3 in for x, and I came out to y equals 5, and then I just interpreted it. It was asking the cost of a child's ticket. We know y is our child's ticket, so a child's ticket costs $5. Okay, on number 10, I want you to go ahead and look at number 10. It's given you a graph. First thing you need to do is get the equation for each one of those lines. So once you've come up with the equation for each one of those lines, then you will come up with the solution on it. So go ahead and pause your video, give number 10 a good shot, and then check back for the explanation. Actually, after looking at the situation, there's no reason to come up with the equations on it. I just looked at the graph. And when I looked at the graph, I could see where the two lines are intersecting. And the question that it's just asking is, what was the average salary in both districts that year, and what year were they equal? So I just looked at where that intersection is, and it looks like it's approximately year maybe 16 and maybe 43,000. So I'm going to just say approximately year 16 and approximately $43,000. So that one was actually a very simple one to interpret just using the graph.